Hi, this is javinkharod, chemical engineer by profession, going to continue our today's topic, type of heat exchanger, advantage, application and design. Heat exchanger are the vital in daily life and engineering, enabling efficient heat transfer between fluid which is crucible for many applications. Help the maintain home during winter and cool engine in vehicle and machinery. By recycling thermal energy, heat exchanger enhance energy efficiency and reduce waste. Now, what are heat exchangers? A heat exchanger is a device that help move heat between two different substances, such liquid or solid, without letting them mix. The process is essential efficiently transferring energy. Heat transfer is essentially movement of heat energy. Amount of energy transfer and rate of transfer are closely related, with heat transfer describing how fast heat energy redistributed. The typical example of the exchanger and heat transfer in which multiple mode of heat transfer, conduction, convection, sometimes radiations, occurs simultaneously with a system. Natural convection happens when heated fluid becomes less dense and rises relative cooler fluid. Heat exchangers are used many industries. They include heating, ventilation, air conditioning, automotive manufacturing, chemical production using heat exchangers. Industries use energy more efficiently, improve system performance and reduces waste. Various heat exchangers are specific need and design enhance performance different industrial applications. Now, it is handy to classify heat exchangers according their characteristics. The main criteria classifying heat exchangers: type of construction, flow configuration, and cooling medium. Now, classification by construction is a double pipe heat exchanger, cell and tube heat exchanger, plate and frame heat exchanger, fin tube heat exchanger. Now, classify by flow configuration is the parallel flow arrangement, cross flow, and counter flow. Now, classification of cooling medium: gaseous, air cooled heat exchanger, or liquid, water coolant liquid. Now, most of heat exchanger, indirect heat exchangers, as they involve heat flow between two fluids, hot fluid and cold fluid. They do not directly mix. In the device, physical barrier such as tube or plate separate the fluid while allow heat transfer through barrier. Example include cell and tube heat exchangers, plate exchangers, fin tube heat exchangers. Now, heat exchangers by constructions. Heat exchanger promote energy exchange between two fluids. They are classified their flow configuration, parallel, counter, or cross flow, and their constructions. Efficient heat exchangers must undergo careful mechanical design and the optimal energy exchange. Double pipe heat exchangers. Double pipe heat exchangers handle various fluids such as liquid, gas, mixture, making them versatile. Diverse applications require cooling or heating. Their flow configuration, parallel, counter flow, optimize heat flow efficiency. Now maintain heat exchanger is straightforward since both pipes are accessible. Cleaning and repair, the minimize downtime, enhance reliability, simple design and lower manufacturing cost, making double pipe heat exchangers economic in small scale use. Counter current flow maximize temperature difference, heat transfer efficiency. Double pipe heat exchangers also scaled large chemical plant and small lab setup. Now, cell and tube heat exchangers. Cell and tube heat exchangers are the tube, hot fluid and cold fluid within a cylindrical cell. They are widely used power generation, refining, chemical processing, food and beverage. Small tube carry one fluid while cell enhance tube bundle. Second fluid. Key component of the cell and tube heat exchanger include tube seal, fluid, vapor that directly fluid over the tube and hence heat transfer. Cell and tube heat exchanger benefit high efficiency due to numerous smaller tubes which create temperature and pressure difference. Made stainless steel corrosion resistance alloy. Cell and tube heat exchanger can harsh condition, manage corrosive fouling fluid, also provide design flexibility, various tube arrangement, size, modular structure, easy maintenance, reducing downtime in industrial setting. Now, example. Cell and tube heat exchanger widely used refinery, manage temperature and pressure differential. Plate heat exchangers. Plate heat exchanger used for refrigeration, food, beverage industries, chemical processing, power plant. It consists stack plant with alternating hot gas and cold fluid passage. Efficient facility, heat exchanger, compact structure, design provide large surface area for heat flow, speeding up temperature changes. The way plate increases turbulence and promote effective heat movement, making them exchange efficient for heating and cooling. Now example, plate heat exchanger, compact design, make ideal use, space restricted area and refrigerations. The term plate heat exchangers encompass various design where heat transfer between thin plate and frame heat exchangers, one of the specific configurations within the category. Specifically, gasket plate heat exchangers. Plate heat exchangers generally consist multiple plate with alternative channel and hot and cold fluid flow through. The plate separate the fluid channel, facilitating efficient heat transfer between them. The frame heat exchanger distinguish frame and casing that support and enclose. Plate provide structural integrity, facility, fluid connection. Example, frame heat exchangers widely used. System to regulate building temperature, food and beverage industries, pressurization, and in chemical processing heat to cool fluid. Fin tube heat exchangers. Fin tube heat exchanger is a standard device, enhanced heat transfer efficiency. It includes tube featuring fins, their outer surface. The fins are enlarged. Surface area available heat exchange increase heat transfer between the two fluid, inside tube and surrounding air, another fluid. Consequent, fin tube heat exchanger output design lacking fins. Design is similar. What you might see everyday appliances. Example, radiator car, coil, back of refrigerator are fin tube heat exchangers. Car radiator. Fin help to transfer heat from the heat hot coolant inside tube and air outside, cooling the engine. The refrigerator. Fins help release heat from refrigerator surrounding air, keep the inside cool. Fin tube heat exchangers enhance heat transfer and they are used various application system, building, industrial process require specific heating and cooling. They are maximum thermal efficiency while saving space, making them practical solutions, everyday life and engineering. Now, scrap surface heat exchangers. Scrap surface heat exchangers are designed handle high viscosity fluid by continuous remove fouling layer from the heat transfer surface, maintain consistent temperature, offer enhanced heat transfer, prevent product degradation. The exchanger are widely used food processing, pharmaceuticals, cosmetic industries. Now classified heat exchanger by medium. There are main two type heat exchanger by medium, gaseous or liquid. Now air cooled heat exchanger, practical purpose and liquid will be divided into water cooled and coolant heat exchanger type. Air cooled heat exchanger are exchanger ambient air to cool hot fluid due to their simple design and lack of moving part. The type of heat exchangers energy efficient, environment friendly and minimal maintenance. They are commonly used energy production, petrochemical facility and refrigeration system. Water cooled heat exchanger. Water cooled heat exchanger are used water primary cooling medium, often configuration, cell and tube, plate design. They are highly effective for large scale heat transfer, offering superior cooling capacity. Compare air cooled system, the exchanger widely used chemical processing system, the thermal energy plant. Now refrigerator-based heat exchangers. Refrigerator-based heat exchanger are refrigerant transfer heat in vapor compression absorption cycle. The main advantage achieve precise temperature control, making them ideal refrigeration, air conditioning, and industrial cooling process. The exchanger are commonly found both residential appliances and commercial cooling system. Now classification heat exchanger flow type. Now different type of flow configuration heat exchanger. They are main flow arrangement, type of parallel flow arrangement, cross flow arrangement, and counter flow arrangement. Now how fluid move the heat exchanger determine heat transfer. Fluid can travel same direction, move perpendicular each other, flow in opposite direction. This type heat exchanger fluid flow same direction with the tube, resulting less efficient heat transfer than counter flow design. However, parallel heat exchangers are generally more straightforward design, require less space, making them ideal scenario with limited space. Cross flow heat exchangers. The setup one fluid move through tube, other flow over their exterior path running perpendicular. Arrangement enhance heat transfer across exchanger surface. It is widely utilized. Application air conditioning system, gaseous and other liquid. The cross flow heat exchanger balance thermal efficiency in compact design. Counter current flow heat exchangers. The heat exchanger two fluid move opposite direction. This configure enhance temperature difference between fluid throughout the entire flow path. Further improve heat transfer compare earlier design. Now application heat exchanger by industries. Where heat exchangers are crucible, numerous industries enable effective heat transfer between fluid and has performance, energy efficiency. Heat exchangers are crucible system transfer heat between fluid to control temperature and humidity, absorb heat, refrigerated space, release heat outside. Example, air conditioning use evaporator and condenser to manage cooling. The saline tube heat exchanger are standard large commercial building for central cooling. Now chemical and petrochemical industries. Heat exchanger manage the extreme condition of the chemical reaction, often involve corrosive high temperature substance. They are used cooling and heating process such as producing plastic or refinery crude oil. Saline tube heat exchanger widely used due to their robustness and allow heat transfer between process fluid and cooling media like water and air. Saline tube heat exchanger are also essential gas processing, condensing and vaporizing gas at different stages. Heat recovery and heat exchangers. Now industrial process, energy system, produce waste heat, regenerative heat exchanger, capture heat and transfer water to air and reuse in various applications. They use indirect and direct heat transfer method, achieve high thermal efficiency. Now heat recovery and heat exchanger sustainability. The industrial process and energy system offer generate waste heat. It is essential capture heat for reuse, employ both indirect and direct heat transfer method. High thermal efficiency, enclose and explore sustainable engineering through three key examples illustrate efficiency and sustainability. Industrial application, machinery, in factory and plant regenerated considerable heat that need recover would be lost environment. Regenerative heat exchanger capture heat transfer water, use preheating boiler and water space heating hot water. Now concept, the mass and physics. What is temperature? If measure average kinetic energy of modular in material, zeroth law of thermodynamics. Temperature, measurable property of thermodynamic system. High temperature object, so more molecular motion, lower ones. The description, extract simple law, heat flow, convection, Newton's law of cooling. The equation, heat energy, Q Newton's law of cooling describes very simple heat transfer process. Q is equal to HA T1 minus T2 means HA delta T, where H represents heat transfer coefficient, A represents surface area, and the coefficient of H include resistance from conduction, convection, radiation, depending on material thermal conductivity, wall thickness, fluid mass flow rate, heat transfer coefficient. Each string is a function, Reynolds number and Prandtl number. Now regarding conduction, copper and stainless steel, which have high thermal conductivity, commonly use heat exchanger constructions. Heat exchangers follow law of thermodynamics. Instead, the energy entering the system equal energy leaving it. Now, it can interpret heat flow from hot fluid equal the energy cold fluid gain idealized system with no heat loss surrounding. Various heat exchangers use specific flow pattern and hence heat transfer. Both fluid parallel flow heat exchangers at one end gradually reducing delta T along exchanger length. Counterflow exchanger fluid enter from the opposite end, maximum delta T improve transfer. Thermal radiation, vital heat exchangers, all object absolute zero emit thermal energy, broad spectrum range, the net radiation, heat loss, and surface area T1, emissivity E, and environment temperature T2 is follow Stephen Boltzmann law. Q is equal to epsilon A E T14 minus T2 raised to 4, unlike Q is equal to HA T1 minus T2, which is assumed linear relationship between temperature difference. Heat flow rate, Stephen Boltzmann law, depend on fourth power temperature T1 raised to 4 minus T2 raised to 4. Demonstrate radiation heat transfer increases exponentially with temperature. Newton's law more suitable modeling convection, conduction, particular lower temperature, while Stephen Boltzmann's law dominated high temperature radiative energy. Now, two type of heat exchanger, many type radiation is relevant. They are fin tube heat exchanger in furnace and saline tube heat exchanger with radiation shield. Now, neglecting radiating heat would lead inaccurate thermal modeling and suboptimal performance. Now, efficiency are the crucible heat exchanger operation. Effectiveness epsilon is the ratio actual heat transfer the maximum possible value. Engineer optimize performance considering fluid flow rate, property and design feature, increasing surface area using fins, tubiculator and selecting material with high thermal conductivity and hence heat transfer. Okay guys, this is up to our today's topic, heat exchanger advantages, application and design point of view. I hope you get sufficient knowledge after watching this video. Next Sunday, we have covered some another chemical engineering topic. Still then, goodbye. Do take good care of yourself.